You should already have your notes out and you should be ready to get going. We're going to be taking some notes over slope, over point slope form, slope intercept form, and standard form. All of the things that you have seen in the Match My Line exercise and the No Sleep Till Brookline exercise. If you haven't finished either of those, after having taken these notes and done the examples, you should be able to go back and see if you can answer some of those questions. What I want you to do as we're going through these notes is to not copy down every single thing you see. Do not copy things down word for word. Do your best to write things in your own words, to glean what is important from what I say and to write things down. Write examples, star things, grab a highlighter, highlight things that you think are important. So the slope of a line is its rate of change. This example describes how slope is applied. Rate of change can be called a couple different things, the grade or the pitch, and change is often symbolized with this little letter that looks like a triangle called delta. So these are a bunch of different words for rate of change or slope. It might be a good idea in your notes to write down slope or grade or pitch or rise over run or delta. Not this whole paragraph word for word, but the important key information. Sort of like this. Though, as you can see, it has some stuff from up in the paragraph and some stuff different. So the equation, y2 minus y1 over x2 minus x1. This is a super important equation. That's worth writing down for slope. We don't have anything about delta here in our equation, so maybe we want to add something in there for delta or grade or pitch. Pause the video now if you want to keep writing what's on this slide. Finding the slope using a graph, we have to be able to find 2 points on the graph. So for instance, if we have this graph right here, we pick any 2 points, we figure out how far up or down we have to go to get from one point to the other, and how far over to the right or the left we have to go to get from one point to the other. Another example, we've got this line here. Once again, you need 2 points. Now these are 2 examples on the same line. So if you notice, both of the slopes are down 2, so that's where the negative 2 comes from, and over 1, that's where the positive 1 comes from. Here's another example. Do you know what the slope of this graph would be? If you said 0, then you are right, because the rise, the number on top, would be 0, and the run between any of these 2 points would be a number. So something like 0 divided by 2, that's a numerical value. How about this graph right here? Well, if we consider the rise over the run, then these points have a rise, so they're going up by 1 or 2, depending on which 2 points you use to measure between. But there's no run, so we're dividing by 0. So dividing by 0, that's undefined. So let's put some of those ideas together. If an equation is linear, constant change in x corresponds to a constant change in y. So those graphs showed an example that any 2 points we picked, we should get the same ratio of changes here. So if we pick 2 points here, we get up 2 over 3. Another 2 points, we get up 2 over 3. The slopes, going back to 2 slides ago where we had those 4 coordinate planes, we have a bunch of different examples of slope. We can have positive slope here. That's where as we read left to right, the line is going up. Or we can have negative slope here. That's where as we read left to right, the line is going down. Or we can have 0 slope. I'd prefer if you called it 0 slope and not no slope. 0 slope where the line is flat. Or we can have undefined slope where the line is straight up and down, and that means that our run would be 0 while our rise would be some number. So linear equations have a constant slope, and this is in the form of a ratio. A ratio is where we have a fraction, some number divided by some number. This ratio we often refer to as rise over run. So that's the formula that you know. That's a ratio. It's y2 minus y1 divided by x2 minus x1. We use that ratio if we know the coordinates of the 2 points on the line. One of the points is x1 comma y1. The other point is x2 comma y2. Alright, we're going to practice this a little bit now. We're going to find the slope of the line that passes through each pair of points. What I want you to do is, in your notes, do these 5 examples. Find the slope for the line that would go through the points in number 1. Find the slope for the line that would go through the points in number 2. And so on and so forth. Once you have done that, please raise your hand and have me, Mr. Crouch, come on over and check that before you go on. Please pause the video now. Okay, now we can graph a line using a point and a slope. So if we want to graph the line that passes through the point 1, 3 and has a slope of 2, what we need to do is we need to take our graphing paper and put that point there on the graph, and then we use our slope to help us find another point. So look on the graph right on your screen and find where the point 1, 3 is. It's over 1 on the x-axis, up 3. You see that point? Good. Now to get a slope of 2, we go up 2 and over 1. So that gets us to that next blue point. We can do this a couple times to find a bunch of different points, and then finally we use our ruler, some straight edge, to connect and make the. So if we're given the point 4, 2 on a line, we know that one's there. How are we going to find the slope of this line? Well, we need 2 points to count in order to find the slope. We can pick any 2 points, but we can save ourselves some time if we're smart and we pick a point that crosses right through the axis. So if I pick that point right there and I find the slope, it's going to be a lot easier than picking a point at random. Go ahead and find the slope between those 2 points. Pause the video now if you're not done. So we've got this right here, 2 points on a line with a little picture showing us how we're going to find the slope. So we choose the 2 points on the line, -4, 4, and 8, -2, and we either count the rise over the run, or we can use the slope formula. So what I want you to do is a little practice using the slope formula. I want you to use the slope formula and one time use -4, 4 as x1, y1, and one time use 8, -2 as x1, y1. You should get the same slope both times. Pause the video right now so that you can do that calculation. Now we can use the graph, that's what we're talking about, to find the slope of the line. This is reiteration right here for probably the 3rd slide in the row, that we can use the graph to find the slope of the line. I want you to do it with this one right here. Go ahead and do that. Then once you're done, raise your hand and let me check your work over this last section about finding slope. Hopefully you've got some good notes written. Go ahead and pause the video now while you find the slope of this one, and then ask me, Mr. Crouch, to come over to see what you've done. Alright, now we're back. We can use slopes and intercepts as well. So we're going to talk a bit about what x-intercepts are, what y-intercepts are, how they're important to us. So first of all, an x-intercept. This is where the line crosses the x-axis. And what's true about all of those points where the line crosses the x-axis is that the y value there will be equal to 0. So anytime the line hits the x-axis, the y-coordinate is going to be 0. On the other hand, a y-intercept is where the graph of a line crosses the y-axis. So no matter where it hits, if the y-intercept is 7 or 21 or -10, the x-coordinate where it hits the y-axis, the x-coordinate of that point where it hits is going to be 0. Now slope-intercept form, this is the one you know, this is the one you used in 7th grade, 8th grade, whenever you, in Algebra 1, to write lines most frequently. It's where we use the formula y equals mx plus b. M is the slope and b is the y-intercept. Standard form, that's one that we've talked about a little bit if you've gotten through No Sleep Till Brookline. If you notice, it's this ax plus by equals c. So that we've got to get the x and the y term onto the same side, and a, b, and c all have to be integers, so we got to get rid of any fractions that we have, and neither a nor b can be 0. So it's a little different than slope-intercept form. We'll learn some more about how to use it and how to recognize standard form. If you're still writing down notes from this slide, go ahead and pause. Alright, now standard form of an equation. We're talking about this standard form a little bit. That's what it looks like, ax plus by equals c. The standard form, you can use this easily to get the x and the y-intercepts to help you make a graph. The x-intercept is the x value of the point where the line crosses the x-axis, and the y-intercept is the y value of the point where the line crosses the y-axis. Alright, to graph a linear equation if it's in standard form. Now this is important stuff right here. Make sure you're following along. If you need to rewatch this part, go ahead and do it. We find the x-intercept by plugging 0 in for y, and then we solve. We find the y-intercept by plugging 0 in for x, and then solving. So say, for instance, we've got this equation right here. If we want to find the x and the y-intercepts, because they're going to help us graph it, we plug 0 in for y. Plug 0 in for y, that helps us to find the x-intercept. We go ahead and solve. 3 times 0 is 0, so that drops out. We divide both sides by 2, and we get x equals 3. That is the x-intercept. And at that point, as I emphasized on the last slide, at that point, y equals 0. Similarly, we need the y-intercept to help us graph it as well. So we plug 0 in for x. We plug 0 in for x, that 2 times 0 drops out. Well, we are left with 3y equals 6. We solve it, we get y equals 2. So the y-intercept is 2. At that point, x equals 0. If you need more time to write down what's on here, go ahead and pause now. So, we're still looking at the same equation. Want to show exactly what's going to happen. It's super important that we understand this standard form stuff and understand how we get the x-intercept, how we get the y-intercept. If you notice, if I take away the y term, I plug in 0 for y, that's going to give me the x-intercept. If I take away the x term, I plug in 0 for x, that's what I do to get the y-intercept. See? We can just cover up the y term to find the x-intercept, or cover up the x term to find the y-intercept. Same solution here. So this is just explaining what I've already explained in speaking, that if you're substituting 0 in for one variable and solving for the other, we can just get rid of the term that you're plugging in the 0 for. And so in the first example, we plugged in 0 there. 3 times 0 gave us 0. And in the second example, we plugged in 0 for the x. 2 times 0 is 0. So those terms do not matter. It's just a little shortcut here to help you when you have a line in standard form and you're trying to get those two intercepts. Pause it now if you need to write down anything from the slide. So if we want to find the x and the y-intercepts of each line, we're going to use those to graph the equation. What I want you to do is to pause now, get each of these into standard form first. Some of them aren't there in standard form. Then solve for the x and the y-intercept of each. And then on your graphing paper, plot the x and the y-intercepts and use those to help you graph lines 1 through 5. Go ahead and pause the video now and do the following work. When you get finished, go ahead and raise your hand and let me, Mr. Crouch, know that you got it all figured out. Okay, we're back here now. We're talking about slope-intercept form now. That's slope-intercept form here. That's y equals mx plus b. You've seen this form before. You know it. This is the one you used in grade school in Algebra 1. The m stands for the slope. The b stands for the y-intercept. Let's go on and learn a little bit about this here. Okay, so an equation whose graph is a straight line is a linear equation. Since a function rule is an equation, a function can also be linear. So what we're saying here is a linear equation is a straight line. We've got loads of functions out there in the world, but not all of them are linear. Some of them might be. And as we pointed out on the last slide, we have m is the slope and b is the y-intercept. Y equals mx plus b. You need to write this down. You need to title it slope-intercept form. We want to use this form when? We want to use this form if we know the slope, right there, if we know the slope, and we know where the line crosses the y-axis. Excuse me. If we know the slope and where the line crosses the y-axis, which is called the y-intercept, let's look at this equation up here at top. We got y equals 3x plus 6. What can we figure out from this equation? Well, we can figure out the line has a slope of 3, and our b is 6, so that the y-intercept is positive 6. Look at another one. Y equals 4/5 x minus 7. The number in front of the x, that is the slope. So 4/5, the slope is 4/5. Now, real quick, a common error I've seen people make before is saying that the slope is 4/5 x. The x is not part of the slope. We look at the number next to x, the 4/5 here, in order to get the slope, but the x itself, not part of the slope. And here we've got minus 7, so b, our y-intercept, is negative 7. And if we want an equation to be in slope-intercept form, the y term needs to be all by itself on the left-hand side of the equation. So if, for instance, we had 2y over here, we would need to fix that before the equation was in slope-intercept form. We would need to divide both sides by 2. Very important because we're going to be spending some time transitioning from one form to another. Why is that true? Because if the y is not by itself, we don't have the same equation. We have to use those 3 rules of algebra to isolate the y term. So, example, just like I was saying there, 2y equals 8x plus 10. Notice that in order to get the y all by itself, we got to divide both sides by 2. After you do that, you get this equation, y equals 4x plus 5. So something you might want to write down in your notes is slope-intercept form. Has to be y by itself on one side. If it's not by itself, go ahead and do the algebra rules, add, subtract, multiply, divide, whatever you need to do in order to get y by itself. Alright, now back to this. Our job is to write an equation of a line after you're given the slope and the y-intercept. Real straightforward. We're moving quick because you guys should know this stuff. We want to get to the more interesting new stuff. So if we're given m of 2 and a b of 9, chug chug, plug them in, y equals mx plus b becomes y equals 2x plus 9. Real straightforward. Let's do a couple more. Given an m of 2/3 and a b of negative 12. If we want to put that in slope-intercept form, right there, m 2/3, b is negative 12, y equals mx plus b, boom, plug it in. 2/3 is your slope, negative 12, your y-intercept. Finally, one last example. M equals negative 5, b equals negative 1. Plug those in. Negative 5 goes in for m, negative 1 goes in for b. So if you thought you needed to write down all of this stuff, you don't. You know this. Maybe write down one example to help you, but don't think you need to write down every word here. So here's 5 questions here. How about you just pick 2 of them and go ahead and do those. And once you're done, go ahead and raise your hand and have me come over and check them. You're going to need to pause the video right now and do those 2 questions in your notes, and then let me know before you restart. Alright, now we can use the slope-intercept form here to help us find the slopes and the y-intercepts. That's the reason for the whole form. So we've got this graph at the right, we've got the equation of the line in standard form and in slope-intercept form. So if we're given the equation, here's standard form up here, if we're given the equation in standard form, remember, we got to rewrite it into slope-intercept if we want to get the slope and we want to get the y-intercept. So, another thing that people sometimes do wrong, look up here. Is this in slope-intercept form? No. This 6, even though it's with the x, it doesn't give us the slope. We don't get the slope until we're into slope-intercept form here. So we've got to get our equation looking like this. All right, so here's some equations here in standard form and examples of how to rewrite the equation, solve for y equals, to get the slope and the y-intercept. So I got 3x minus y equals 14. What am I gonna do here? First of all, I gotta get that 3x over to the other side. So I subtract 3x from both sides. That gets me to this line right here. Negative y equals negative 3x plus 14. I got negative y. I got to fix that. So I divide both sides by negative 1. And dividing both sides, look here, remember it's dividing every term by negative 1. So I get y equals 3x minus 14, which would tell me the line has a slope of 3 and a y-intercept of negative 14. A different way we could have solved it here. Instead of subtracting the 3x first, I could have added the y over to the other side to get 3x equals y plus 14, and then subtracted the 14 over. Two different ways, same answer, y equals 3x minus 14. Second example, x plus 2y equals 8. So I go ahead and subtract the x over to get 2y equals negative x plus 8, and divide both sides by 2. And then here I have my final equation, and y equals m, slope of negative 1/2, x plus b, y-intercept of 4. So here's a couple equations for you to go ahead and write in slope-intercept form. How about you pick any two of these and go ahead and try them? Pause the video now, and when you're done, raise your hand and have me come over and check. All right, on to our next form, point-slope form. We can use this equation when we know a point and a slope. This is the most powerful form of a linear equation. Write down a new header, point-slope form, and make sure you're paying attention here. This is the one we want to use most frequently, the easiest one for us to use, because we only need to know a point and a slope. Any point. That's what makes it so powerful. Any point. We don't have to know something specific like the y-intercept or the x-intercept. Just any point. So on the line, here, let's start up here where my highlighter is. Suppose you know that a line passes through the point 3, 4 and has a slope of 2. We can quickly write an equation of the line using the x and the y coordinates of the point and using the slope. The point-slope form of the equation of that line that passes through the point x1 comma y1 with slope m is right here. Y minus the y coordinate of the point equals m. M stands for the same thing it stood for before, that's the slope, times, and we got to remember our parentheses, don't forget these parentheses, x minus the x coordinate of the point. So we take our point, x1, y1, we plug that in for x1 and y1. We take our slope, we plug that in for m, and boom, we've got an equation. This is point-slope form. We can do this anytime we know a single point on the line and the slope. All right, that's the important thing. Write down here is this equation, and maybe to write down that x1, y1 is a point on the line, and m is the slope of the line. All right, so let's try a couple here, real straightforward. Using point-slope form, write the equation of a line that passes through 4, 1 with a slope of negative 2. So y minus y1 equals m, x minus x1. That's our equation. 4, where does that go? Okay, that's the x coordinate of the point. It goes in for x1. 1, where does that go? That's the y coordinate of the point. That goes in for y1. And our slope, negative 2, always goes in for m. I plug those things in. I'm here in point-slope form. Now remember back to what we did in the last section. We can solve this to get it into slope-intercept form if we want. So we could distribute the negative 2 to each thing, and then we got negative 2x. Negative 2 distributed to x gives us that. Negative 2 distributed to negative 4 gives us the plus 8. And then we don't have y by itself yet, so I got to add 1 to both sides. Now, on your test, for what I want you to do, I don't want you to even do this unless I specifically ask you to do it. If I just say, write an equation for a line that passes through the point and has a slope of negative 2, your final answer can look like this. Leave it in point-slope form unless the question says, get y by itself, or get it in slope-intercept form. Another example. Using point-slope form, write the equation of a line that passes through negative 1, 3 with a slope of 7. -1 in for x1, 3 in for y1, 7 in for slope. Boom. Got it right here. The only thing that I would ask you to do is you should know that if I have minus -1, that's the same as writing +1. Please do this simplification to get down to this. This stuff down here about writing it in slope-intercept form, don't even look at it. Don't care about that. All right, so this is an important application of point-slope form right here. If we know 2 points on the line, do we know a point and a slope yet? No. So how can we use point-slope form? First, we got to use the 2 points to find the slope. So maybe make a little note under your notes right now for point-slope form. We're still under point-slope form, and write how to use it with 2 points. So if we have 2 points, here's how we use it. We use the 2 points to find the slope, then we use a slope and a point to find point-slope form. So step 1, find the slope of the line. So if we were given these 2 points on a line, first thing we got to do is find their slope. So we use our slope formula, which you have written down from yesterday, y2 minus y1 over x2 minus x1. Plug them in. So we got our y coordinates, 1 minus 3. And remember, we got to go in the same order with our x coordinates, so -2 minus -4. Simplify down, we get a slope of -1. All right, going on. Now we use either point. We can use either point here to take this equation and write it in point-slope form. So let's use the -4, 3. So the 3 goes in for y1, the -4 goes in for x1, and our slope that we got on the last page, -1, goes in for m. So y minus 3 equals -1 times the quantity. Brackets act the exact same as parentheses here. -1 times the quantity, x minus -4. And remember, the only simplification I want you to do here is to fix this stuff. If we have minus -4, make it +4. This stuff down here, write in slope-intercept form, you don't need to do that unless the problem asks you to. I care about this right here. Can you do this? I'm not so concerned about you getting it into slope-intercept form. All right, let's review some of this stuff about all these equations. There's often many ways to do it. So we can write this as a review of all, a new section in our notes here. Slope-intercept form. When do you use it? So you should have slope-intercept form written there. And then when written right under it. When, you know the slope and you know the y-intercept. If you know the slope and the y-intercept, you use this form. If you need to pause right now, go ahead and do it because I'm going on. Point-slope form. When do you use this? So you should write down point-slope form. When? If you know a point and the slope. And also write down if you know 2 points. If you know 2 points, you want to use this. So 2 cases. If you know a point and you know a slope, use this. If you know a point and another point, use this. Pause now if you need because I'm going on. Horizontal lines. All right, this is a great time to talk here. Horizontal lines are y equals 3 or y equals 10 or something like this. Lines that are horizontal have a slope of 0. So I hope you have horizontal lines written down there. And a little note under that, every horizontal line has a slope of 0. The rise over run formula for the slope will always equal 0 since the top, the rise, is 0. So you could put it in y equals mx plus b and then put in 0 for the slope and then 0 times x. Well, that's 0, so that's going to go away. Or you could just be smart and remember a horizontal line is always going to be y equals something. So if we have, it's always going to also be if the y coordinate of a point it goes through. So if we have a horizontal line that goes through the point 1, 3. It's a horizontal line that goes through the point 1, 3. What's the y coordinate of that point? 3. So the equation for that horizontal line, y equals 3. A horizontal line that goes through the point 7, -8. What's the y coordinate of that point? -8. So the equation for that line, y equals -8. Vertical lines. These lines have no slope. I don't like that term. I don't like no slope or it does not exist. So write down vertical lines, write down your example, and then write down that they have undefined slope. Right here it says this. The rise over run formula for slope has a 0 denominator, and dividing by 0, that's undefined. So they have undefined slope. Now here's a common error. Lots of people will see a horizontal line and see undefined slope and think, oh, I have undefined slope. How am I going to write an equation? The lines still have equations. They're just opposite of horizontal lines. All horizontal lines were y equals. All vertical lines are x equals. And instead of taking the y coordinate like we did with horizontal lines, we take the x coordinate. So a line that goes like this across a graph, horizontal, we take the y coordinate of a point it goes through. A line that goes like this, vertical, all we need to know is what x value does it go through. So a vertical line that goes through the point 1, 7, x equals 1. All right, so here's this, everything that we said over the last couple of minutes here, depending on how many times you had to pause and go back. Here's it all listed in one chart. If you want to look at this to copy anything down, go ahead. But if you've been following along so far, this is all just review right here. This stuff you already have written down. So actually, there's one thing to ignore here. Point slope form, when we're graphing it, put it into y equals form to easily graph. You can do that, but you could also graph it straight from point slope form by putting your point on the graph and then using your slope to find a new point. I'd rather you do it that way. Put the point on the graph, x1 comma y1, put a dot there, and then use your slope, say it's up 3 over 1, to find another point and put it on your graph. Up 3 over 1, find another point, and then connect them with a straight line. Now here's some important things. Remember, if a point lies on a line, its coordinates make the equation true. So if this is our line, y equals 2x minus 3, we can tell that 2 comma 1 is on the line, because when I plug it in, both sides are equal. 1 equals 2 times 2, that's 4, minus 3. So it's on the line. All right, this stuff over here about getting your equation into y equals form before graphing it, you can do that, but you don't need to all the time. You don't need to. That's one way to do it, is to get it into y equals form before graphing it. Just one way to do it. Okay, we've got a few then just review questions here. If you'll notice, they're not in order, but whatever. Do the questions as they show up. What I'm going to do is I'll come to the slide with a question. I'll wait 5 seconds, and then we'll say the answer. So when you get to the slide, pause it, see if you can figure it out, and then hit play, and I'll go through the answer. So I'm going to start my 5 seconds now. All right, this is false. How could you know that real quick? Well, first of all, if you know about positive, negative, 0, and undefined slope, you'd know that this has a negative slope. So there's no way it could have a slope of 3 over 2. It would have to be a negative slope. So let's just count here. So from this point, let's go from this point right there to this point right here. That's this point on the graph all the way down to here. So starting here, I have to go down 1, 2, 3. So that's negative 3 for the rise on top. And then the run on the bottom is over to the right, 1, 2. That's positive 2. So negative 3 over 2 would have been correct here. All right, the answer to this one is A. So negative 5 minus 3, that's negative 8 on top. 4 minus negative 2, that's 6 on the bottom. So when we simplify that, negative 8 over 6, we get negative 4 over 3. All right, so this was a different way to represent a line. This right here, 1 comma 2, is a point on the line. 3 comma 5, a point on the line. 5 comma 8, a point on the line. So let's pick 2 of those points. Let's use these 2 and find the slope. So the difference in outputs, 5 minus 2, is 3. Divided by the difference in inputs, 3 minus 1 is 2. So our answer, 3 over 2. All right, hopefully you got this one real quick. Undefined lines, or undefined slope, silly me, there's not an undefined line. Undefined slope means a vertical line. The only one of these that is a vertical line, x equals -5. X equals a number is a vertical line.